This thing that belongs to somebody says, oh, you know, you do this.
Okay, we got a test 1 week from today. Did you guys know that? No, you didn't know that? We also have no class on Friday. Friday is your spring break. So we're going to try to review on Monday. I'm going to put a review sheet up. I'm going to see how far we get today before we decide how far this test will be. So remind me before we leave. Typically, I go through the section 4.1 and 4.2 of chapter 4 for the ending of the test. So if we can get through 4.2, 4.2 is very short. That's my guess, is that we'll go there. The test starts with section 3.3, where we learn the derivatives of the other functions. And then we had the stuff with the motion moving along a number line with the velocity and acceleration. That was in section 3.4. The chain rule in section 3.5. 3.6 was implicit differentiation. 3.7 was related rates. 3.8 was the linear approximation and the differential. 4.1 is finding the extrema on a closed interval. And then we'll see if we're going to add 4.2 or not. So I'll put that in parentheses. So I'll put a review sheet once I know how far we're going to go, which means I have to go all the way to my office from here. I don't know if I'm going to. I'm just going to curl up in the fetal position and stay here until the weather turns better.
How far is your office?
My office? My office is probably, it's right there on Memorial Circle where the math building is. Yeah, well, where's your dorm? Well, see, you got farther than I do. Maybe I'll just stop at every building on the way. Yeah. Now, we will try to review on Monday. And I say try because I'm leaving for the basketball game in Indianapolis Friday morning. And we don't, if we win, we play on Sunday, but the game time on Sunday has not been assigned. We booked 2 flights, one Sunday afternoon and one on Monday. Sunday afternoon means I'll be here on Monday. But the flight that we booked on Monday, if we play late on Sunday, won't get me here in time. And I don't know. And I think I would be traveling during the time that we would meet. So I'll send you an email over the weekend when I know. You know, I probably jinxed ourselves that we'll probably lose on Saturday now, because I guess we're playing Friday, right? Friday, Sunday. Yes. So I probably jinxed ourselves by saying that I've got a flight home on Monday. That's bad juju. You don't do that in sports. But I will do something, some version of a review for you. Somehow, if I can't make it to class, I'll I don't know, I'll send me your questions and I can Zoom it in the evening or something like that. I'll figure out something to cover for you, but we'll plan on meeting on Monday as usual. I'll send you an email if something changes.
So even though Monday is like in the air, would it be possible to have like a pre-recorded thing?
Yeah, that's what I could say. I could do something and put it on Blackboard. I could work through the review sheet for you, or if you send me questions from web work or stuff like that, I can do a recording and put that on there. Some version of a review. I can do that. I plan on being here. We'll see. We play the early game on Friday, so I anticipate if we win, we play the early game on Sunday, which means we probably would be able to get back to Lubbock. I don't know. Putting all the basketball in one city was a good plan, but all the flights are, there's no flights. Okay, so we'll get you covered. I'd rather leave the test so that you have time to do it on Wednesday, because Wednesdays are long. Okay. All right. So do you have questions for me about what we've done so far?
I have 2 web work questions.
Okay, let's do your 2 web work questions.
It's number 5.
For which web work is it? This is the one that
3.8 to
covers
4.1.
the 3.8, 4.1?
Yes.
Okay. So tell me what's number 5.
Let y equal 2x squared. Find the change in y, delta y, when x equals 2 and delta x equals 0.1.
Delta y. So none of these work well. When x is equal to 2 and delta x is 0.1.
Yes.
All right, those two are guys.
It also asks for the,
Differential in y.
yes, I found that. So find the differential when x equals same thing, dx equals 0.1.
Okay. So what that means is we've got this parabola here. Y is equal to 2x squared. And we need the y value when x is 2. Then we need the y value when x is 2.1. And then the change in y is y2 minus y1. Okay? So that's what the change in y means. So if you're given an x value, you need to find the y value. Plug it in, right? So y2 is the 2.1. We're going to put it right in here. And y2 is going to be 2 times 2.1 squared. Then y1 has a 2 here instead. So now we got to square 2.1. So that's the part that finding the exact change in y is not comfortable. We'll do it. We take 2.1 times 2.1 by multiplying 21 with 21. And then I had 2 decimal places, so I put 2 decimal places. So 2.1 squared is 4.41. And 2 squared is 4. So I've got 8.82 minus 8. So the exact change in y is 0.82. Our approximator to the exact change in y is this differential in y. And the differential in y is just given by the derivative at the nice point times the change in x. Our derivative is just 4x. So we put the nice point in there, which is the 2, and the delta x is the 0.1. So I get 8 times 0.1 is a 0.8. Okay, so you can see that dy is roughly equal to the exact change in y. You said you had another one?
Yes, number 7.
Number 7. Make sure that's clear to read. And then I just go over here. Number 7. All right, tell me what number 7 says. Oh, I found a good one.
A cubical box is constructed from 3 kinds of building material. The material used for the 4 sides of the box costs 2 cents per square inch. The material for the bottom costs 3 cents per square inch. And the material for the lid costs 4 cents per square inch. And then it asks to estimate the additional cost of all the building materials if the length of a side increased from 20 to 21 inches.
Okay. So if you have a slightly larger box, how much larger is your cost? Essentially, this is what is being asked. So how much larger? We want to find a change in cost. So we can find the exact change in cost, and then we can find the approximate change in cost, or the approximate change in cost would be the easier calculation. Our approximate change in cost will be d of the cost function. So let's figure out the cost. A cube has all the sides the same length. X by X by X by X, let's say. Okay, and so we're going to write out the cost by being the cost of the sides plus the bottom plus the lid, and those are all per square inch. So we'll take those cost numbers and multiply them with the square inches or area of each of those sides. And since we're all squares, all that areas are x squared, right? So for the 4 sides, I've got a 4 for the sides, then the 2 cents, and then the x squared. The bottom just has 1 side, and it's 3 cents for the x squared. And then the lid is 4 cents for the x squared. So if I add all that together, I have 8 plus 4 is 12 plus 3 is 15. Our cost function is a total of 15x squared. So the exact change in cost is the cost at the bigger length minus the cost at the smaller length. So it's going to be 15 times 21 squared minus 15 times 20 squared. Does it want the exact cost? Exact change in cost?
He wants the approximate number.
Okay, okay. So I've squared 21 already. That was a 441. So I've got 15 times 441 minus 15 times 400. It might be easier for me to calculate this if I factor out 15. So I'm going to do that. Factor out the 15, do the subtraction first and then the multiplying. So we're going to multiply 15 with 41. So I'll do 15 times 40 plus 15 times 1. 4 times 15 is 60. So 15 times 40 is 600. And then 15 times 1 is 15. So this should be 615 cents. It will cost 615 cents more to construct the box whose sides are 21 inches long compared to the one who's 20. So that's the additional cost. Now the approximate cost is our dy, which is just going to be c prime times our delta x. Our c prime is just 30x. X is the length of each side. So what is delta x here? What's the change in x over there? Just 1, right? Delta x is just 1. So I put the nice number in here, that would be the 20, and then I put the 1 in for delta x. So it's 30 times 20 times 1. So that's so much easier, right? 600 cents is the approximation. Okay. Anything else? Anybody else? Anybody? 9? What does number 9 say? In the interval from -3 to 3. X to the 4th minus 8x squared. Is that correct? And then you want the absolute max and the absolute min? Yeah. Okay, so this is what we ended class with last time. So let me reiterate what we're doing. Remember that a continuous function defined on a closed interval attains a largest value called its absolute maximum and a smallest value of its absolute minimum it attains both of them. It has one value that's larger than all the other values, and one value that's smaller than all the other values. Might not be one value, might be a tie. But there's going to be a largest value, there's going to be a smallest value. Guaranteed or your money back. We have a continuous function here and we have a closed interval. Now I need to go look for them. So the problem tells you how to look for them. It says find the critical numbers. So the candidates are the critical numbers. Those are the x's where the derivative is 0 or where the derivative is undefined. Okay, the candidates are the critical numbers in the interval. And the two endpoints of the interval. So what we're going to do is collect the critical numbers, collect the endpoints, plug them in here and look at the y value. An absolute value, an extreme value is a y value. So we compare all the y values at those points, and then the largest is the max, the smallest is the min. So start by taking the derivative and setting it equal to 0. There will be no places where this function has no derivative because it's a nice, smooth 4th degree polynomial. It's going to have 3 terms in it at the very most. Take the derivative. And we'll get 4x cubed minus 16x. Set that equal to 0 and see if you can solve for x. I'm going to factor out a 4 and an x. And that leaves me an x squared minus 4. X squared minus 4 factors again. That's factors is the difference of squares. X minus 2, x plus 2. Get 3 factors, so we have 3 critical numbers. This factor is 0 when x is 0. This one's 0 when x is 2. And this one's 0 when x is negative 2. Those are the critical numbers. All 3 of them are in the prescribed interval, so they're all going to be candidates. let's now plug and shove. We want to find the value of this function at each of those points. So 3 critical numbers, 0, 2, and -2. And then the 2 endpoints, -3 and 3. Okay, I'll put a 0 in each of these. I get 0. 2 to the 4th is 16. 2 squared is 4. 4 times 8 is 32. So I'm going to get a -16 here. The powers on each x are even, so squaring a -2 is going to give me the exact same thing. So here the 3 and the -3 will have the same value. Let's see, 3 to the 4th is 9 times 9, so that's 81. 3 squared is 9, 9 times 8 is 72. So that looks like those values are going to be 9. So I got an ordered pair at 0, 0. I have an ordered pair at 2 and -2, set y value of -16, and then 3 and -3 have a y value of 9. So 9 is the largest value in that list, -16 is the smallest. -16 is the absolute min. And 9 is the absolute max. Is that easy enough?
Sorry, in Word, I know like for, I use like the endpoints are also.
No, the endpoints aren't critical points, only the values with a derivative of 0. The endpoints are candidates for the location of the absolute max and min.
What's the difference between the absolute extrema and the absolute minimum? or
The
maximum?
absolute
Is it just
extrema
different
is the
terms?
collection of both of them. Extrema is
Okay.
for the extreme
So
values.
it's like terminology.
Yes, yes. So if I say, give me the absolute max and absolute min, a quicker way to say it is identify the absolute extrema. So I got a whole bunch more of those if you want to try more. We did that one. Let's do the ones I got on this sheet here. Okay, so this is section 4.1. That's what this is. So find the extreme values. F of x is equal to 2x cubed minus 15x squared plus 24x plus 7 on the interval from 0 to 6. So I'm going to give you a bit to take the derivative, factor it, set equal to 0, and solve for x. But first acknowledge that you've got a continuous function because it's a polynomial, and you've got a closed interval. So you know you're going to get a max and a min. You get two critical numbers and tell me if they're both in between 0 and 6. They're both in there? What are your two critical numbers? All right, let me see if I agree with you. My derivative is 6x squared minus 30x plus 24. So if that equals 0, and as I do that, I'm gonna pull out a 6. So I have an x squared minus 5x plus 6. We need factors of 6 with the same sign that add to -5. So I'm going to vote for 2 and 3. Right?
4.
That's right. It should be a 4, shouldn't it? 6 times 4 is 20. So I am going to go with 4 and 1. You are right. Good thing you know how to factor and not me. Okay. X minus 4, x minus 1 gives us x is 4, x is 1 as our critical numbers. They're both between 0 and 6. So our next step is just to find the y values. So I want those two numbers, 1, 4, and then 0 and 6. So let's see, when I put a 1 in, 1 to any power is 1. So I can just add the coefficients. 2 minus 15 is a -13. -13 plus 24 is 11. 11 plus 7 is 18. Going for partial credit. I'm going to plug in a 0. I get 7. Now we got the dirty numbers. Okay, let's see. 4 cubed is 64. So I have 2 times 64. 4 squared is 16. And I'll have to do 4 times 24 plus 7. Okie dokie. Let's see. This will be 128. 15 times 15 is 225. Take 225 and add another 15. Gives me 240. Yep. 4 times 24. 4 times 4 is 16. 8, that's 96. Plus 7. Okay, 128 plus 7 is 135. 240 plus 96 is 336. Maybe that's a -201. Yes.
Wouldn't that be plus 96?
Oh, it would. Same numbers. Okay, let's try this again. I said 128 plus 7 was 135. 135 plus 96 is 231 minus 240. How about a -9? It was quite the difference. Here's the real tricky part. We're going to do this to 6. Let's see. 6 times 6 is 36. 36 times 6 is 216. 9, 8, 15 times 36. 24 times 6 plus 7. So I've got my plus signs in the right spot. let's see, this is 432 minus, okay, 10 times 36 is 360, so 5 times 36 is half of that. 540. 24 times 6 I did, no I didn't. 6 times 4 is 24. 12, 13, 144 plus 7. All right, so here we go again. 7 plus 144 is 151. 151 plus 432. 583 minus 540 is 43. Thanks for all the help. So I look at those numbers, -9 is the absolute minimum, and 43 is the absolute maximum. Okay, no more polynomials. Sick of polynomials. Let's do something else. Okay, what is it?
Absolute extreme.
Okay,
F of x equals 4x over x squared plus 1 on the interval -4 to 0.
all right. Do your quotient rule. Take your derivative with the quotient rule. And see how much you can simplify it. You need to find out where your derivative is equal to 0. It's not showing up so well.
4x.
All right, so using the quotient rule, f prime of x. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So when I multiply out the top, I get 4x squared plus 4 minus 8x squared. All of that is divided by the x squared plus 1 squared. And so 4 minus 8x, 4x squared minus 8x squared is a negative 4x squared. So I'm getting 4 minus 4x squared all over x squared plus 1 squared. I'm going to keep going. I'll factor the numerator. We'll pull out a 4. And then factor 1 minus x squared as 1 minus x and 1 plus x. So let me back up a minute. We always have to make sure that we have a continuous function. And we start with a rational function, so we have to make sure the bottom is never zero. Well, the bottom is never zero, period, because it's always positive. X squared is positive, and I'm adding a number to it, so that's strictly positive. Since the denominator is never zero, we know we have a continuous function on a closed interval. Okay? And over there, the x squared plus 1 squared is never going to be zero. The sum of two perfect squares is always positive. So the only thing that makes this derivative zero is when the numerator is zero. And the numerator is zero when either 1 minus x is zero or 1 plus x is zero. So our two critical numbers are x is 1 and x is negative 1. We throw away the x is 1 because it's not in the prescribed interval. Okay, so let's get rid of x is 1. That one's not in the interval. So we just keep x as negative 1. And then we look at the y values about the 3 points. X is negative 1, x is 0, and x is negative 4. So when x is negative 1, my numerator is negative 4. My denominator is 2. So my y value is a negative 2. When x is 0, I get a 0 on top. So that makes the whole fraction 0. And when x is negative 4, I get a negative 16 on the top. 16 plus 1 is 17 on the bottom. So I'm looking at those three numbers, negative 2, 0, and negative 16 over 7. And my decision is that the negative 2 is the absolute minimum. And the 0 is the absolute maximum. Okay? Good. I'm glad we were able to do a quotient rule problem. Now we're going to do trig function. Let's see. Let's let f of x be the square root of 3x minus 2 times the cosine of x. And how about we're looking for the interval from 0 to 2 pi. And we know that this function's going to have an absolute max and an absolute min. What do you know about the cosine of x? Got a picture of it in your head? Cosine of x is continuous function, right? So if I combine a continuous function with another continuous function, like a polynomial of some sort, the difference between two continuous functions is continuous. So I have a continuous function on a closed interval. Both the max and min exist. So you're going to take the derivative, set equal to 0, and see if you can find all of the critical numbers between 0 and 2 pi. You love your trig, I can tell. You love your trig.
I hear that, right? That says that the acid.
Yeah. -1, that's a -4. -1 squared is 1, plus 1 is 2. Did you put a negative to it? What?
It asks for X values, not your Y value.
Ah. Well, you knew that.
Yeah.
Let's say, let me read it. Let me read it. Yep, it's asking for the x's, not the y. So give me the x's now. So x is -1. It's going to give you the x on there. Yes, ma'am.
So for the square root of 3x, is that times -2x per
Subtracting. Square root of 3x minus 2 times the cosine of x. I think you'll get 2 critical numbers. Maybe.
Almost.
Where are you stuck? Are you stuck on the derivative?
No.
Okay, tell me the derivative.
Square root of 3 minus or plus 2 sin it.
Now we're going to set that equal to 0 and solve for x by first solving for the sine of x.
Oh, gotcha.
Right? It's not going to factor for us. So I'll move the square root of 3 over. Then we're going to divide by 2. And we have to figure out the angles at which the sine is a negative square root of 3 over 2. So we can get a reference angle, and then we would go project it into whatever quadrant sine is going to be negative in. So think of your little trig values. Give me a reference angle in quadrant 1 that makes the sine square root of 3 over 2. Give me the quadrant 1 reference angle. Pi thirds. Pi thirds. Sine of pi 6 is a half. Sine of pi thirds is square root of 3 over 2. Okay, so our reference angle is pi thirds. Now, which quadrants is the sine going to be a negative value? 3 and 4. So to get the angle in quadrant 3, you go pi thirds beyond pi. To get the angle in quadrant 4, you go pi thirds not quite to 2 pi. So pi thirds plus pi is 4 pi thirds. All right. So then that make 5 pi thirds in quadrant 4. Okay, both of those are between 0 and 2 pi, so we keep them. And then we compare the y values at those 2 points and the 2 endpoints. Now we go to our table. We got 4 pi thirds. We got 5 pi thirds. And then we got 0 and 2 pi. The cosine at 0 and cosine at 2 pi are both the same. What's the cosine at 0? It's 1. So at 0, I have the square root of 3 times 0. minus 2 times 1, that's going to give us a -2. At 2 pi, we have the square root of 3 times 2 pi minus 2 times 1. So that's 2 square root of 3 pi minus 2. We might have to pull out a calculator to figure this one out. Okay, now let's do the 4 pi thirds. What's the cosine at pi thirds? 1/2. 4 pi thirds is in quadrant 3, so cosine is negative in quadrant 3. So this is going to be a negative 1/2. But here I'm going to have square root of 3 times 4 pi thirds minus 2 times a negative 1/2. So let's write that as 4 square root of 3 over 3 times pi plus 1. 5 pi thirds is in quadrant 4, and the cosine is positive 1/2 in quadrant 4. 5 pi thirds. So we have the square root of 3 times 5 pi thirds minus 2 times 1/2. So 5 square root of 3 over 3 times pi minus 1. And I haven't a clue which one of those is the largest. So I'm going to whip out a calculator. Well, you're going to whip out a calculator, because I don't have one other than my phone. Calculator, where's my big numbers? No, don't give them to me. Did they do away with the calculator that does scientific calculating?
Is your rotation right?
I don't think so.
Did you just, you have to like go and then your phone them all? We can.
Those are not. I'm really relying on you guys. It's not giving me anything but the goofy
Is
numbers.
your screen locked?
I don't think so. Don't know how I tell from my card game.
I got 2 pi's in this. Zeros.
My screen is locked. Okay, you got who?
I got 2 pi's in that.
Give me your numbers here. Which one?
Okay, so 2 pi was approximately 8.88. And then 5 pi over 3 was approximately 8.068. And 4 pi over 3 was approximately 8.25.
So I guess we're pretty clear that this one's the absolute man. This is the only one that's negative. And then this one is apparently the absolute max. Okay. Thank you. I couldn't give you anything with calculator type things on the test, but I did want you to be able to find critical numbers. Okay, got another one here. We've got a logarithm with it. Let's do the same. So f of x is equal to x squared minus 8 times the natural log of x on the interval from 1 to 4. X squared is a continuous function. The natural log of x is a continuous function. And so the difference between two continuous functions is still continuous. And then I have a closed interval. So I know I've got my requirements of being able to find the absolute max and min. So I'm going to give you a minute to take the derivative. Your logarithm is going to give you a derivative that's a fraction. So get a common denominator once you've taken your derivative. And then see if you can write your derivative as a single fraction. So hopefully your derivative looks like 2x minus 8 over x. And then you get a common denominator. Multiply that first fraction by x over x to give you 2x squared over x minus 8 over x. When you factor out the 2, you've got x squared minus 4 as the other factor, so that factors again. You get x minus 2, x plus 2. Our derivative has a denominator, so our derivative is not going to exist where the denominator is 0, and that's at x is 0. But not to worry, that's not in the interval. So we eliminate that candidate. Then we get a candidate at x is 2 and at x is negative 2. So f prime does not exist at x is equal to 0, and then f prime is 0 at x is 2 and negative 2. And then we're in the interval from 1 to 4, so we throw away this one, and we throw away that one. Those two crossed out in my barely green marker are not in the interval from 1 to 4. Okay? Eliminate those two. So we have only one critical number in the interval, then the two endpoints of the interval. So the one critical number in the interval was 2, and then 1, and then 4. So we need 2 squared minus 8 times the natural log of 2. 1 squared minus 8 times the natural log of 1. 4 squared minus 8 times the natural log of 4. The natural log of 1 we should know. Do we? 0. Natural log of 1 is 0. So this value is a 1. The natural log of 4, we can write that as the natural log of 2 squared. And then we can use that log property that brings this 2 down in front. So I can say that this number is the same as 16 minus 16 times the natural log of 2. And it might help me compare the size. If I factor out the 4 here, I have 1 minus 2 natural log of 2. If I factor out the 16 here, I have 16 times 1 minus the natural log of 2. So to me, it looks like that this is going to be a negative number, right? Here is the natural log function. There's the 1. So the natural log of 2 is about here. Natural log of e is 1. E is a little bit bigger than 2. So this is not quite 1. So I know it's about 0.7. Natural log of 2 is roughly equal to 0.7. So this is 1 minus 1.4. So that's roughly equal to a negative 1.6. This is going to be a positive number. As I said, natural log of 2 is about 0.7. So 1 minus 0.7 is roughly 0.3. So that's roughly equal to 4.8. So that one looks like the max. And this negative number here is the min. So are you aware that natural log of 2 is about 0.7? Let's take all a minute, stand up and stretch, make a restroom run or something. Let's take a little bit of break.
Do you have a joke for us?
Gosh, I don't have any jokes. I have homework for me though.
Are you excited about the game?
Kinda, it's much more fun, you know, when there's people. There's 25% occupancy. And my husband, we play in Bloomington, and that's where my husband got his PhD from Indiana. So he was all excited to show me all of his old stomping grounds. I said, you don't know that Indiana's open, right? It may not have the open activities that Texas has. So anyway, he'll take me around a little bit and show me where he used to live. And I'm excited about seeing the campus. I always like to go to another college town and look at their campuses.
Have you been to all the NCAA tournaments?
I guess since he's been president, I have. What I didn't go to many. That's good perk of the job, though. I had a messy one and I had one more trig one. So we'll do 2 more of these when everybody's back. You guys have a lot of friends who actually got a spring break? Well, that's
You and I
good.
still have one, so all my friends there are on spring break this week.
Yeah.
My
Right.
mom and sister, they're on spring
A couple of my friends came to Lubick.
Yeah, all of
And I
my
was
friends
like,
were in one group, and I was like, why are you going?
I went out this weekend and a couple of my friends from out was like, oh, I'm out at the bars right now. Come find me. Why are you like,
Yeah, literally.
Because we're open.
Everyone has been coming here and I'm like, stop, do not stop. No.
My son is home for a few days. He's a coach at Houston Baptist, and he was off. So he split his spring break between me and the girlfriend.
How generous.
I know. Because she's working. She's not on spring break. She's working. And he's still buddies with a lot of his middle school friends and all, so they all got together at my house last night and I cooked for them all. I'm a terrible cook, but I just grilled fajitas, so that was kind of easy. It was it's so cute because now his friends have like babies. And I remember them when they were running around on the soccer field themselves.
You know, when you look right across, right here, is that like the, like, is that, do they have like a White House for like the president or do you?
Oh, no, we
Okay.
have our own house. There's not a
I
president.
didn't know
so-
if they had like a house that they
Uh-uh.
just had to move out of.
Nope, nope. Live in the same home I raised my children in.
That's cool.
I'm gonna give you another one here. I said another trig one and then a messy one. Another trig one and then oh, that's not a bad one there either. Okay, let's do the trig one first. Huh.
Very considerate adventure.
Right?
All right, on 0 to 2 pi, this thing is going to have some critical numbers. It's a continuous function because the sine of x is continuous, sine squared is continuous, and the sum of two continuous functions is continuous. So not counting the two endpoints, you should get 3 critical numbers. Be careful how you take the derivative of sine squared. Think of that as all of the sine is squared. So you can use the power rule. Bring the power down, raise it to 1 power less, and then multiply by the derivative inside. The derivative should look like, the cosine is minus the sine. And now the power rule over here, bring the power down, raise this to the first power, then the derivative inside gives me a cosine. Like that as your derivative. And now that one is factorable because I have a common factor of sine. So when you put the 0 over here, let's pull out the common factor of sine. And that leaves me a -1 in the first slot, plus 2 times the cosine of x. Then we collect our critical numbers by setting each of the factors equal to 0. So I need to find out where the sine of x is 0, and I need to find out where 1 plus 2 cosine of x is 0. So name me all of the places where the sine of x is 0. I know sine of 0 is 0, so is the sine of 2 pi, right? Where else? What is it?
-2.
Uh-huh.
I mean, like
Pi. 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 Next, we need to find out where 2 cosine of x is equal to 1, which is where the cosine of x is 1/2. Cosine is going to be positive 2 places, in quadrant 1 and in quadrant 4. So what's the reference angle in quadrant 1? Pi over 3. So what's the quadrant 4 version of pi over 3? 5 pi over 3. So the 2 endpoints are also critical numbers in this example. And then the 3 other ones, we're going to plug them all back into here. Zero pi, 2 pi. Pi thirds. And 5 pi thirds. So we want the cosine of 0 plus the sine squared of 0. Sine of 0 is 0, cosine of 0 is 1. So that gives me a grand total of 1. And the cosine of pi plus the sine squared of pi. But the sine of pi is 0. What's the cosine of pi? It's back there, so it's -1. Cosine of 2 pi is 1. Sine of 2 pi is 0. So that was going to be a positive 1. Cosine of pi thirds and 5 pi thirds are both a half. So let me go ahead and put a half in here. Sine of 5 pi thirds is going to be the negative of the sine of pi thirds, but we're squaring. So whatever number I get here is going to be the same thing I get there. What's the sine of pi thirds? And the hint is there the cosine was a half. 3 over 2. So when I square that, I get 3/4. So I have a half plus 3/4. 2/4 plus 3/4 is 5/4 for both of these. 5/4 is bigger than 1. So that makes 5/4 the max and -1 the min. Okay. So let's do one more, a bit on the messier side. Do the same for f of x is the square root of x times x minus 5 to the 1/3 on the interval from 0 to 6. So let's be careful. Let's make sure this thing's continuous. I've got a square root function multiplied with a cube root function. As long as x is positive, I can take square roots. That's a nice continuous graph. I can take cube roots of anything. So that's continuous. The product of two continuous functions is continuous. So I do have a continuous function defined on a closed interval. You're going to get both an absolute max and an absolute min. To take the derivative, write the square root of x is x to the 1/2 and do the product rule. And what we're going to try to do is take your derivative after you've done the product rule, write it with positive exponents, because you're going to get some negative exponents. Negative exponents mean that you're going to have some fractions. Try to write your derivative as a single fraction with a common denominator. So remember when I told you not to worry about simplifying your derivatives? I lied. You need to know how to simplify your derivatives. So I'm going to take the derivative, make sure you got the right derivative, then I'm going to give you some more time to simplify it. I'm going to do the product rule. So here's the first times the derivative of the second. You take one away from 1/3, and I get a -2/3. And the other way, second times the derivative of the first. Like that. Now take those two terms with the negative powers and put them on the bottom. Over here, the 3 will be on the bottom, and so will this, but it's only underneath this term. Here, the 2's on the bottom, as long as with this x, and it's under that term. So then get the common denominator. Oh, I'm gonna go write a test today. Darn. I do have to go to my office. You want to get it as a single fraction? Anybody? algebra whizzes? Who's making eye contact with me? I've got a lot of top of the heads going here. All right, so like I said, I'm going to put the 3 and the x minus 5 to the 2/3 on the bottom. Then for the next one, I'm going to put the plus sign here. The x minus 5 to the 1/3 is on the top because its power is positive, but I get a 2 times x to the 1/2 here. Is that okay? And the common denominator is the product of the two denominators. So I got to put this up here and that over there to get the common denominator. Let's see if I got a red one here. Red, purple or blue, let's see if one of these works. Over here, I got to multiply this fraction by 2x to the 1/2 over 2x to the 1/2. I'm going to multiply this fraction by 3x minus 5 to the 2/3 over itself. And now they have the common denominator of 6 times x to the 1/2 times x minus 5 to the 2/3. Remember when you multiply like bases that you add the exponents? So 2x to the 1/2 times x to the 1/2 is just 2x. We'll have a 3 here, but again, you add exponents. This is a 2/3 power and a 1/3 power. So I'm going to end up with an x minus 5 to the first power with the 3 in front of it. So I have 2x plus 3x minus 15 all over that denominator. So I have a 5x minus 15 there. So I've got 3 critical points because I've got 3 factors of x. 2 of my critical points make the derivative undefined. So those are possible places where there's a sharp corner or a vertical tangent line. And then where the numerator is 0. So first, f prime is 0 when 5x minus 15 is 0. So when I solve that for x, I get x is 3. F prime does not exist when this x to the 1/2 is 0 and when x minus 5 to the 2/3 is 0. So this occurs when x is 0. The reason there's no derivative there is it's an endpoint. Remember, there's never a derivative at an endpoint. Right? This is not defined when x is negative. And then x minus 5 to the 2/3 is 0 when x minus 5 is 0. And that's when x is equal to 5. And that's probably a place that might be a sharp corner or a vertical tangent. But I got 3 critical numbers, 0, 3, and 5. And every one of them is in the prescribed intervals. We keep all 3 of them. How close did you get to that? Close? Close, close? Get all three critical numbers? All right, now I'm going to plug them back into the function. A 1/3 power is a cube root, and then the other one's a square root. So I've got 3, 5, 0, and 6. So the first one's going to look like the square root of 3, and 3 minus 5 is a -2. And so then I have a -2 to the 1/3. So that's going to be a negative something. The cube root of a negative number is negative. When I put a 5 in there, this is going to be 0. So I have the square root of 5 times 0. So that's just going to be 0. When I put the 0 in there, the first factor is 0. So I'm just going to have 0 again. And then we're going to have the square root of 6 times, well, 6 minus 5 is 1. 1 to any power is 1. So this is the only negative number in the list. That has to be the absolute minimum. And the square root of 6 is bigger than 0, so that has to be the absolute maximum. Okay.
Can you please go ahead? Like after you multiply all that.
You see why I chose to do that? Why that's the common denominator?
Yeah.
Okay, so I needed 2, 3, x minus 5 to 2/3, x to the 1/2. So this was missing that factor, and that was missing that factor. Okay, so 2 times 3 gives me the 6, and there's the x to the 1/2, and there's the x minus 5. So now working on top. When you multiply like bases, you add the exponents. Half plus half is 1, so this is just 2x to the first. Same deal here. When you multiply like bases, you add the exponents. 1/3 plus 2/3 gives me x minus 5 to the 1. And then this 3 came from the common denominator. Now I'm going to distribute the 3. So 3x minus 15 plus that 2x. And now that gives me a 5x minus 15. And I took up there. So take each factor, set them equal to 0. Okay. Because polynomials are boring, aren't they? You want some more excitement in them. Do you need another one, or are you happy? How about one with an exponential function? One more. I promised you no more, but I'm giving you one more. So let's do f of x is x times e to the negative 2x. On the interval from 0 to natural log of 2. E to the any power is a continuous function. And so when I multiply that with another continuous function, x, then I've got the product of two continuous functions is continuous. So there aren't any breaks in this graph. You should be able to find some critical numbers. I think there's only going to be one critical number. Let's see if you can find it. Take the derivative using the product rule. Keep in mind, e to the power is always positive.
Is that on the whole thing or just e to the negative?
Just e to the negative 2x. So it's x times e to the negative 2x. Do your product rule. If you can factor your derivative, You should get one critical number in the original. The critical number is not too bad. It's not a funky place. Just comparing size, and after log of 2 is again right around 0.7. So the critical number you find is going to be smaller than 0.7. Who's got one? You do the product roll. Here's the first. What's the derivative of the second? All right. And now here's the second times the derivative of the first. So you can just take the parentheses away and write that as minus 2x e to the negative 2x plus e to the negative 2x. So you can factor. You got a common factor of e to the negative 2x.
Wait, do e to the negative 2x, see that derivative.
There's the derivative of e to the negative 2x. That's first times the derivative of the second,
So why wouldn't we
plus
bring
the
down
second times the derivative of the first.
Why wouldn't we bring down all of the negative 2x? Because we should look at it like e to the x.
Right? The derivative with respect to x of e to the u is itself times the derivative of the exponent. Right? So I get itself times the derivative of the exponent. Right? Remember, you're going to get past that at graduation.
But why is it not negative 2x times e to the negative 2x?
Well, it is after I simplify. But why do you want it to be negative 2x in here? But remember, it's itself, e to the negative 2x, times the derivative of the power. Power is negative 2x, so its derivative is just a negative 2.
Got it.
I want that to keep you from graduating. Diploma's gonna.
You think you'd actually do that?
Okay, so let's factor out the e to the negative 2x. If I can tell him to do it.
I've never shown my face again.
These students. Everyone would ask, why did you do that? What'd you do? And he'd be like, "Oh,
I brought the whole power down. I only needed to take the derivative of the power. All right, look, I factored out the e to the negative 2x, and the other factor is negative 2x plus 1. E to a power is always above the x-axis, so this factor is never 0. This factor is 0 and negative 2x plus 1 is equal to 0. And so that's when negative 2x is equal to negative 1. And so I told you you'd get a nice little critical number right there to half, and it's smaller than the 0.7.
So you can't do e to the negative 2x.
Even negative 2x is never 0. Right? You can't, there's no solution to that equation because e to the power is always above. Here's e to the power, here's e to the negative power.
It'll never hit 0. Okay.
Never hit 0. Usually you try to take the natural log of both sides, and you can't take the natural log of 0. Right? So this can't happen. So we only have one critical point, and then the two endpoints, we're going to plug them back into here. So our critical number is a half, and then 0, and then natural log of 2. So when x is a half, I have a half e to the negative 2 times a half, which is 1/2 e to the negative 1. E to the negative 1 means 1 over e. So this is like 1 over 2 times e. E is roughly 3. So that's almost 1/6. When x is 0, I'm multiplying by 0, so my y value is 0. Now here we're going to have natural log of 2, e to the negative 2 natural log of 2. All right, let's figure that out. When you raise a power to a power, you multiply exponents. Right? And what's e to the natural log of 2? 2. So this is 2 to the negative 2. What's 2 to the negative 2? 1/4. So this number here is 1/4. So it's the natural log of 2 times 1/4. So I said this is roughly 1/6. Natural log of 2 is 7/10, right? 0.7. So this is roughly equal to 7 over 40. Which one's bigger, 1/6 or 7 over 40? Well, let's get a common denominator of 240. So 6, that's about 40 over 240, and this is about 42 over 240. Right? So this one's slightly larger. If you did this on the calculator, let me see, did I do this on the calculator? That this one, no, I didn't do it on the calculator. Maybe we need it. Oh, so which one did I say was the biggest? That one? I was wrong. You did this on a calculator. That's dang close. That's 0.17. Did this on the calculator. That's 0.18. So my approximation was off. This is the max. And 0 is the min. Again, another one we needed the calculator for. But I wanted to show you some where you had to work a little bit to find critical numbers. All right, so that says page 105, 205, and 305. Where's 405 and 505? Interesting. We don't have them. You don't want to do 2 more pages of that, though, do you? So I will mention what's in section 4.2, but I won't put 4.2 on your test. Your test will end with this, section 3.3. And 4.1. So I'll go make sure I get that review sheet posted. But let me tell you what's coming up. Yes.
So I was flipping through my notes and
after 3.4, we like jumped to 6.4. Is that what I'm-
No, that shouldn't be 6.4. I probably just mislabeled it.
That makes more sense. 'Cause it's like-
Well, that's what happens when I teach Cal 2 on the same day that I teach Cal 1. Because we're in chapter 6, and
I was gonna say, I'm gonna get the book with chapter 6.
that's all right. We only go through chapter 5 in this class.
I just take what you write and then put down, please.
Don't write what I write what I write. Write what I mean to write.
But I guess we go on. I was super confused because we were talking about going to 6, and I was like, we just jumped 3 minutes.
Oh.
What is happening?
And nobody stopped me. So let's go through the organization again. 3.3 were the derivatives of the other functions, our 6 trig functions, e to a power, and the natural log function. Those were the basic functions, just of x. All right, we didn't get to the chain rule until we got to section 6-ish. Section 3.4 was the motion calculus, where you have the first derivative is the velocity, the second derivative is acceleration, and we were talking about a particle moving on the number line or a particle being thrown. So this was the, I don't know, I call it motion calculus. Section 3.5 was the chain rule. So that's the biggie. Large percentage of our problems are going to come from the chain rule. 3.6 was implicit differentiation. So we had your basic implicit differentiation. We had higher derivatives using implicit differentiation. Then we derived the formulas for the 3 inverse trig functions, exponential functions of other bases, log functions of other bases. And then we also had that logarithmic differentiation. So that's another big section. Remember when we were taking a derivative, say, of x to the sine of x, and you had to first take the log of both sides so you can bring it down and then do the product rule? So there's a lot in this section as well. 3.7 was related rates. What kind do you want here? We had volumes changing, areas changing, right triangles changing. Those are the kind of things that we were looking at here. 3.8 was the differential in the linear approximation. And then 4.1 was the stuff that we just did here, the absolute max and mins. So I think I can make a decent test over that. That's only what, 7 sections. It'll all be outlined for you on your review sheet. I won't change it. Yes, ma'am.
So since we're having this test on Wednesday, do we get the full 2 hours?
Do you want the full 2 hours?
Last test, I didn't know exactly how much time we had, so I just brushed through it like, please,
Yeah,
I have enough
absolutely.
time.
And then at like 1, I looked up and everyone was still working and I was like, it's up to them.
Yeah, no, I had to take a panic attack at like 12:50. I was like, wait, is she gonna cut us off? Because it was gonna be on a Monday.
Are you guys gonna panic? Where's your composure? Do I need to bring a wet glove and slap you every now and then?
Well, I guess that's 2.5 chapters.
Of all the things that you encounter in your life, taking the test is way down there on the things to stress about. Way down there.
Whenever I have a test, I just think to myself, remember that test in 10th grade that you failed? Doesn't matter now. No. So this won't later either.
Well, when I look at you, all I see is that test you failed in 10th grade.
Yeah, I made that up.
You know what, in graduate school, when I scored double digits on a test, I was like, yes! I made a 12! I'm kicking ass now! Everybody else made 69. I made a 12 and I was,
No, that's terrifying.
High school
Oh.
calculus. I don't know if it was the teacher, but I did not learn anything. I'm learning so much in here, but those tests, I got a 0 on one.
well, see, been there, been,
I
not
went
high
through
school,
all of
but,
high school without learning math, so I'm a little, I
okay.
missed out on like a foundational part.
Oh, I'll bring some soothing music.
Thank you.
I'll walk around and pat you on the head. You're doing well.
Screaming or
Well,
meditation.
take a long walk beforehand. That's always supposed to, my college roommate had anxiety attacks on tests, and she went to a psychologist who told her to do relaxation exercises and take long walks. I told her study harder. You wouldn't panic if you studied harder. So those aren't all good advice?
No, I bounce- whenever I'm anxious, I bounce my lip, and that's all fine and dandy, but that's also what I do to go to sleep, to get my energy out.
Wow.
And so it works for a little bit, and then 30 minutes later, I'm like, oh, I'm so sleepy.
Get up and take a lap around the room. We've got a big room. Okay, so I'll go to my office later today and try to post a review sheet. If I don't blow over walking over there, but I've got a class now for another hour, so don't expect it until later today. I'll have this outline. We've got web work through 4.1, and I'll let you know on Sunday the status of my trip home. Okay?
Your tests are far less stressful than like chemistry tests that are like, if you have a poster in your room, you're gonna fail. So make sure you don't look at your paper for too long.
Well, you don't have to worry about that in here.
So
No,
But-
chemistry tests are like, did we even do these types of problems?